Okay, this is a recording for 2-1, hopefully. The word's a little slow, so bear with it. We're going to go over the homework questions. The word's a lot of slow. Okay, so 2-1, sorry for the delay. Number 1, determine whether the slope at the indicated point is positive, negative, or 0. At D, it is a negative slope. You can clearly see it here. Okay, we're just going to go over answers for right now because these are pretty straightforward. Number 2, answer is B. Determine whether the slope at the indicated point is positive, negative, or 0. B, it's positive. Okay, this is just basic 9th grade math here. Determine whether the slope is positive or negative at this point, and it is positive. A for 3. Number 4 is positive B. Number 5. Okay, 5 is the definition, the limit definition of the derivative. Sometimes it's called the difference quotient. It's basically the slope formula expanded a little bit, and it was a limit on it. So the answer to that is C. We'll go over that in a minute when we do some more problems, how to do that. Number 6 is just like 5. Notice that the answer has to have a limit as delta x goes to 0, and the function has to be plugged in correctly. Letter B is the one that's plugged in correctly. You're depositing x plus delta x into everywhere you see an x up here in the function, and you're doing a slope formula. So the change in y is on top over the change in x, and the limit as delta x goes to 0. Use the definition derivative. I would give you these answers, but we're going to go over how to do them in a minute because they're not necessarily straightforward. Did anybody get number 8 correct? 1, 2 people, 3 people got 8 correct. I can zoom this out a little bit. Here's easy to see. And I'm going to turn off the light. Now, you have to do this at first in calculus. We have to do it the long way. Eventually, I'll show you a shortcut way to do it. So if you got it right and someone showed you the shortcut way, you're not doing yourself any favors. You have to do this the long way. So does everybody have those answers recorded? Okay, which one do I need to do? Yes, Mason. You can speak. Number 9? Okay. That actually, number 9 looks like it's wrong. So did you get 2x for an answer? Okay. So number 9 is wrong on this paper. It should be 2x. Now see how quickly I did that? It was because there's a shortcut way to do it. However, I know there's somebody in here that needs to do the long way, perhaps. Did you get them all right? Do it the long way? You get it? Okay. Did you get any wrong? No, no. You did it the long way? Okay. Which one? Okay. So number 9 was positive 2x. That is incorrect. Okay. Did we do 11 or no? That's as far as we went. Okay. So I need to show how to do this for Veronica and Simeon, who aren't here. So let me do number. Which one do you want me to do? Number 8. Okay. Number 8. Okay. This is. It's pretty systematic how you do this, and obviously, just like any other math, if you leave out a step, you're going to make a wrong turn, and it's going to be detrimental. So first of all, you're going to find the derivative. The derivative is represented by f prime of x. The formula, or the method in which we're going to do it, is we're going to use the limit, and we're going to use, instead of delta x, I'm going to use h as h approaches 0 of f of x plus a little bit, which is the second x value, minus f of x, which is the original x value, all over h. Okay, that has to be memorized. On the test, you have to write that down. On the final exam, you got to write that, and then you have to continue with your substitution after that. So there's a couple ways to do it. You can say, well, first of all, f of x is equal to x squared plus x. And then you could say f of x plus h, just for so you don't mess up, is going to be wherever I see an x, I'm going to plug in x plus h. So this turns into x plus h squared plus, I got another x here, and I got to put an x plus h in for that. So that's going to turn into x plus h there. Now we're going to put it all, well, I can do the math on this. I haven't put it into here yet. So these things are going to go into here eventually, but I haven't put them in there yet. I'm going to do a little algebra first off to the side. So I'm going to square this out using FOIL. So you square the ends, and then h times x plus h times x is 2xh plus h squared plus x plus h. Okay, and you can combine nothing here. Okay, so that's going to be the f of x plus h. So now we're going to put it into this formula. I'm going to put this all over h and take the limit and let h go to 0. Okay, so how do I do that? Well, let's write out the formula. Again, for most college classes, they want you to write everything out. So I'm going to show you it that way. I write the limit each time. So I'm going to put in f of x plus h, which turned out to be this. So x squared plus 2xh plus h squared plus x plus h minus f of x. Well, f of x is x squared plus x. And a lot of times, if you're going to make a mistake on these things, all over h, it's forgetting to distribute this negative sign to both things here. It's a common mistake in calculus and in algebra that kids make, teachers make, everybody makes. So f prime of x continues to be the limit as h approaches 0, and we're going to combine like terms up here. We'll distribute the x, so this is the negative, so the negative x squared minus x. Now we're going to combine like terms. So x squared and negative x cancel. Negative x squared, x and negative x cancel, and then left behind, don't call me Cameron, left behind is going to be h squared plus 2xh plus h all over h. Okay, that allows me to continue here. I still can't plug in a 0 for h. If I plug a 0 for h, I'm going to get a 0 on the bottom. Doesn't work. However, because of algebra, and that's why they teach you how to do algebra in 9th grade, so you can do stuff like this. At least that's what I've surmised over the years. The limit as h goes to 0, this is going to turn into, we're going to factor out an h, and we're going to have h plus 2x plus 1 all over h. This allows the h's to cancel. And then when I substitute, now I can use the substitution method for my limit. The limit as h approaches 0 of h plus 2x plus 1. Since there's only one h left in the problem, well, it doesn't matter if there were 1 or 2 or whatever. Now we can sub it in, and you're going to once you take the limit, you're going to get 2x plus 1 is the derivative of that function. And the original function was x squared plus x. The original function was x squared plus x. The derivative of that function is 2x plus 1. Now, what does that mean? You should be, well, first of all, make sure everybody's on the same track, or right track here. Does that make more sense? Got other questions about it? Okay, so it's more of minding your handwriting. Be careful of your cancellations, and it works out nice. However, with practice, you get used to these, and you miss one sign and forget it. It's done. Now, what this thing is, this is a parabola. X squared plus x is a parabola. What's its roots are at what? So x squared plus x. What are its roots at? Anybody know? What is across the the x-axis? Okay, so crosses at 0 and 1, or negative 1. I'm sorry. So 0 and negative 1. Let's say negative 1's here. It's a happy face parabola. It crosses the x y-axis there. Okay, so I'm just going to sketch it for right now. It's not necessarily the exact shape or the exact spot. Let's just kind of put it in there a little bit. I don't even know how far down it goes. I don't know what the minimum value is, but it's just a sketch right now. So we got that parabola right there. What this formula, so this is the function. So we see f of x equals x squared plus x. Okay. Now, at any point on this function, you should be able to tell me what the slope is using this formula right here. So this is the derivative. I think I spelled that right. But it's also the slope equation, I call it, equation. And that's not mathematically proper or whatever, but it's a slope equation, any point on that parabola. So if I put in this point right here, say we do put in that point, which is negative 1, 0. If I put a negative 1 into this slope equation without doing the math, what's the slope at that point? What's the slope at this point? Like what we did at the beginning of this packet. Slope is going to come out to be positive or negative. Tell me that first. Negative. So when I put in this negative 1 into my slope equation here, f prime, the derivative at negative 1, or the slope at negative 1, I get 2 times negative 1 plus 1, and I get negative 1, or negative 2 plus 1, which is negative 1. So the slope here, the slope, or the rate of change at that point, negative 1 comma 0, I'm just noting it so you know, is negative 1. So if I were to pick a point over here on the other side of the parabola, let's say it's 10 or whatever, I don't know what that point is. Well, it could be 1, it could be 2, anything greater than 0. Anything greater than 0 is going to give me a positive slope. And the further I go out on the x-axis, the steeper my slope, because this thing's a parabola. Okay, so when you find the derivative, you're finding the slope equation for any point on the line. And it's called the instantaneous rate of change. So at that point, that's what the rate of change is. If this parabola represented motion over time, so it's like 0, 1, 2, 3, 4, 5 seconds, this object would be going faster and faster each time, because at first its slope is gradual, and then it gets steeper and steeper and steeper as you go up here. So over time, this thing's going really fast. Yeah, that's not a good representation of objects moving. Maybe, I don't know, a rocket, I don't know, whatever. If you're riding your bike, it's probably a good representation of how fast you're going. Your bike would disintegrate probably if it was going that fast. So what you need to gather from last night's homework and this lesson in general is, so looking at this, that you need to know the limit definition of the derivative. You need to be able to use it. You need to understand what it represents, that it represents the derivative, and it represents the slope equation, which also is the slope of the what line? Well, these little lines are all what kind of lines? Yes? It's tangent line. So the slope of the tangent line. And now that you know the slope of the tangent line, you can actually find the equation of the tangent line because you have a point and a slope. Again, way back in 9th grade math, why do we need to know point and slope form? For this stuff. So you can figure out movement in calculus. At least that's the way I see it as a teacher of high school math. That's what I've surmised. I'm going to pause the video. I think Veronica and Simeon, you got enough information for this. So we're going to stop. So I hope you feel better. God bless you. And hopefully this helps. Glory to God in the highest.